My name's Tim Foster. I lead the agricultural economics and rural livelihoods work package for the project. So I'm going to be presenting some of the work that we were doing in the last year and some of building on the first 2 years of the project. So this is work of a sort of a wider team at Manchester, including two of our postdocs, Tom Higginbottom and Roshan Adhikari, one of our PhD students, Sarah Rediker, and also Relitza Demova, who's a development economist in GDI. This is work that's predominantly taken place in the Volta River Basin case study area. So I'll be talking mostly about sub-Saharan Africa. And it's work that's been done jointly with two key partners without whom we really wouldn't have been able to get any of this work done. So Samuel Gug at Waskal in Ghana and Sander Zwart, Benjamin Gansar and Komlovi Akpoti at IMI in their Ghana office. So to give a bit of very brief background, so what's the sort of, why are we focusing on sort of irrigation development in sub-Saharan Africa as part of FutureDAMS? So as little as 4% of cultivated land in sub-Saharan Africa is currently irrigated. The figure on the left-hand side gives you a bit of an idea of the sort of the breakdown by sort of regions, but also how that sort of feeds into issues of food insecurity and rural poverty across the sub-Saharan African region. So this covers particularly our sort of Volta Basin and Nile Basin case study areas. And irrigation development, including dams as part of that, is seen as a key way of improving rural livelihoods, I guess through three mechanisms. One, through helping farmers to close yield gaps by better buffering production against rainfall variability and droughts. Also by increasing cultivation intensity so farmers can cultivate year round. And then obviously as we move into an era of much greater hydrological extremes, it's also a means of building resilience to those climatic and hydroclimatic changes. So our work has really focused on sort of three main questions. So first of which, what has been the performance of past large-scale irrigation investments, and particularly those associated with dams in sub-Saharan Africa? There's been a large amount of irrigation projects constructed already in the region, particularly in the latter half of the 20th century. What has been the outcomes of those schemes and what can we learn about those in terms of moving forward with future planning? Secondly, what are the alternative modes of irrigation development that exist, and are they any more or less productive, profitable, and effective in terms of meeting the needs of farmers and rural communities in the area? And again, what does that mean in the context of thinking about larger scale dams and water infrastructure projects? And then thirdly, based on sort of 1 and 2, what are the sort of mix of policies and investments and technologies that we need to enable intensification of irrigation in sub-Saharan Africa at the food, energy, water, I guess I should say food, energy, water, environment nexus, particularly thinking about potential implications of intensifying irrigation for water resource sustainability and other users. I'm going to focus mostly on 1 and 2. 3 is something that I think is an area we're hoping to go into more in the final sort of year or so of the project. So looking first at the first of those questions, so the way we've sort of started off trying to tackle this problem. So this is work that Tom Higginbottom has led here at Manchester. We've looked to collate planning documents for about 80 irrigation schemes constructed between about 1960 and 2010 in different parts of sub-Saharan Africa, and look at what they proposed in terms of irrigated areas that would be delivered as part of those schemes, and then compare those with satellite-based estimates of the irrigated areas that the projects are currently delivering. The findings are not particularly positive. If you happen to be an irrigation scheme planner, the average scheme is delivering about 16 to 18% of the proposed area it was expecting to deliver. And there's a large proportion of schemes, the bars on the sort of the far left of the figure, where the scheme is now completely defunct and has collapsed entirely, and there's no agricultural production happening at all. Slightly more concerningly as well, there doesn't seem to have been any trend in performance improvement over time. So we don't see any statistically significant relationship between dams being constructed more recently and their performance outcomes, suggesting that scheme performance hasn't really been getting better over quite a substantial period of time. So this is work that is currently in press in Nature Sustainability, so should hopefully be out in the next couple of weeks. It may actually be out by the time the annual forum takes place, and I think we'll be saying a little bit more about that in some of the events during the week. Just to reflect a little bit on what we've sort of learned about why these trends are observed, 3 kind of key points have come out. This is tied in with Tom's work, but also with a paper that Sarah Rediker currently has in preparation. That there's 3 kind of factors underlying poor levels of performance. One is that there's a systematic overstatement of what is actually an achievable level of irrigation development from a lot of large-scale projects. And there's a variety of reasons for that, but it's in part to provide justification for the viability of the project, as well as due to the fact that it's just inherently hard to assess what is the potential rate of delivery on a lot of these projects. And we see very similar trends in the literature for hydropower projects and also for wider large-scale infrastructure projects, both in the developed and developing world. There's also mismanagement between the goals of many irrigation schemes, often pitched as solutions to improve national food security, particularly following periods of food price spikes or significant natural disasters. But these are misaligned often with the needs of farmers. If you're farming on a scheme, you want to make money out of it, you want to improve your livelihoods, and often that's not easy to do if you're being told that you need to cultivate rice or other staple-based crops to support food security. And this creates a bit of a vicious cycle that farmers are therefore not able to pay into the maintenance and long-term upkeep of the schemes. So eventually, when the money does run out from external donors, you end up in a sort of a build, neglect, rebuild type cycle where projects gradually degrade and decline in performance over time. And this is sometimes exacerbated by wider social and political factors. One of the things that we found has been quite hard is that it's very difficult to actually explain the underlying reasons why some schemes fail and some schemes don't. It's often a nuanced local context that matters. But one of the things that does come through as an important regional driver is government effectiveness. Less effective, less well-managed governments have a harder time keeping developments in operation over longer periods of time. So given this, what we've then been moving on to do is look at the fact that really these sort of dam-based irrigation schemes are not the only forms of irrigation that exist on landscapes. There's lots of other types of irrigated agriculture that can be found across sub-Saharan Africa. These are sort of 3 examples from northern Ghana. So riverbed pumping on the left, small community reservoir schemes in the center, and groundwater irrigation, in this case, a sort of a hand-dug well in the right-hand side. And these are all sort of a variety of types of systems that are used by farmers as a means of accessing water for irrigation purposes. So what we've been looking to do is try and better understand what kind of benefits they provide. So we've been conducting surveys for around about a year or so now in the Upper East region of Ghana, and we've been able to show that these sort of informal irrigation systems, as we call them, do improve the productivity of agriculture. So we've got rice yields and pepper yields, so 2 major crops in this area. I can see that informal irrigators do a lot better than non-irrigators in the dry season, which is when pepper's grown. Non-irrigators are not actually able to cultivate at all. And also that this has then a benefit for livelihoods of rural communities. So here, if we see the sort of the revenue generated from the proportion of crop harvest that's actually sold, we see that going from being a non-irrigator to an informal irrigator gives you a big boost in terms of the revenue that you're able to generate from agricultural production. That's both due to higher yields and the ability to cultivate year-round, which then means you have more harvest that you can free up to sell to generate income. One of the things that's noticeable is that informal irrigators seem to do less well than those within the sort of big government managed irrigation schemes in the area. And a bit of context for that, though, is that those informal schemes are serving a much larger number of farmers and also much less expensive to construct. So this is work that's still ongoing, but our initial results are suggesting that actually some of these smaller scale irrigation investments might actually be a more cost-effective solution than some of the approaches built around large dams and very large pieces of water infrastructure, at least from the perspective of improving agricultural productivity. So in terms of kind of ongoing work that we're doing now to build on that, what we're looking to do is to try and understand a bit more the spatial extent of informal irrigation, particularly within the Volta Basin. We hope to be able to scale this up to some of the other basins later in the later months of the project. So figure on the left is showing some work that's been led by Benjamin Gansar at IMI with our support, looking at mapping the spread of small reservoirs in the Upper East region of Ghana. So we're seeing a big growth in those that are partly being driven by government policies around the sort of the One Village, One Dam program. And on the right, some work building satellite-based remote sensing tools to map the location of informal irrigation areas across wider landscapes. We're then also looking to do some deeper sort of dive field assessments, so more detailed household surveys. We've had to obviously adapt those a little bit in terms of what we were planning because of restrictions posed by COVID, but I think we've been able to keep those on track. And what we're using those to try and do really is to try and understand some of the sort of subtle differences between different types of informal irrigation systems and how those influence characteristics of water use and livelihood and yield benefits achieved by farmers. And then on the right, back to some more sort of larger scale analysis being led by some of the team at IMI, looking at trying to take all this information and say, okay, this is how much informal irrigation is currently on the landscape. Can we understand and map what the potential areas are that could be targeted for future development and upscaling of these systems in the future? And then the final area that we're working on is then trying to think about how that sort of sits within the wider water resource system. So linking some of that mapping and field assessment work with crop water modeling tools, so we can start to quantify what impacts both the current areas and potential future areas might have on regional and basin scale water balances, but also try and take some of the particularly earth observation based tools and methods that we've been developing in the project and wrap those up into some toolkits and open source software that decision makers can then use as part of their, I guess not day to day, but season to season management of irrigation investments and irrigation schemes across the landscape. So this is work that is still in the earlier stages, but we hope to have some of those developed by early next year. These 3 images are showing one example of how we're using this. So this is the Tono irrigation scheme in northern Ghana. The image on the left is 2017, in the middle 2018, and on the right 2020. And the green areas are the sort of the agricultural production areas. So it's showing how we can use these approaches as a way of monitoring changes in performance of existing investments over time, and that use those also as a way both of informing realistic projections of future investments, but also to enable decision makers to track where problems may be occurring in specific pieces of infrastructure to enable targeted interventions to improve sustainability. That is what I have to say on the work that we're doing.